Hi everyone, really good to see you today. Matthew Kennedy here doing my video talking about Module 5 about the development of algebra. And I know it's supposed to be about a paragraph or two if you write it out, so I'll probably do about 6-7 minutes and go from there. So we're talking today about the development of algebra. And with being a future teacher, how can we connect that to our future students? Now, algebra is a big backstory. You know, how do we get to where we are today? And it started in Islam with a guy named Al-Khwarizmi. And what this person really did was he pretty much laid the framework for, there's been some controversy. And in the reading in Hodgkin chapter 5 really highlights it a lot about how, well, look, the Babylonians did some quadratic work, so why are we giving this all to Al-Khwarizmi, right? So there's some questionable things about that as well, but when we really think about what algebra is, that's the biggest connection, in my opinion, to my future students. When we think about mathematics, arithmetic versus algebra, this goes to the Stanford video. Don't know that professor's name, but the hour and 40 video. But that video was really about what is actually algebra. And it's a qualitative thinking process. And algorithms, models, ways, yeah, we use numbers. Yeah, it kind of does sound like, arithmetic. But we really think about the practical use for a function that could be used for all values of x or all values of the variable. That's really where algebra comes in. When we're just plugging in some numbers here and there, some quantitative work, I could see it. But when we think about solving for x, when we think about a thinking process for how to solve for x, now that's when we're really starting to use the ideas of algebra. And really, what I took away as well from the second video, which was about planes and other stuff, we really think about, I wrote in the notes here, a little bit about aviation and lift and velocity, and really, it showed a great application of quadratics to our everyday life in aviation. And it pretty much says, well, how can I lift this so-called plane? Well, let's go faster, and there's a v squared involved. So if we know our, I forget what they call, I think they call the direct relationship. Lift is directly related with velocity. If I increase velocity, I increase lift, right? It's not inversely related, because if I increase velocity, if I decrease lift, that would be inversely related. So you really think about, my future students, and we think about, okay, well, how can we really think about how we can use this in our everyday life? Well, if you're a pilot, and yeah, it is common sense for us, but that's what the video talked about. It pretty much said, look, you increase velocity, you can increase the lift. And it goes for other stuff too. That's just an example. Maybe there'll be some equations in algebra that, again, can be inversely related. And it's the idea of using those equations, thinking about them qualitatively, and how can we go about them in the practical and everyday use in our life. And a big part about going back to Al-Khwarizmi, what he did with the book of completion and reduction, which it probably wasn't really as good as the elements, but it was still a great, one of the best Arab books there were, in the world to be ever written. But he really laid the framework of utilizing some of these vocabulary terms. What is a square? A number? What is roots? Okay, I think those were the 3 words. It's in Hodgkin. Yep. Roots, squares, and numbers. And essentially what he said was, he said, look, we're going to find solutions to these practical everyday problems. And where some problems came up was, hey, look, you know, I have a negative answer. What does that mean? Or I have a fractional answer. You know, can I utilize that? So just because Al-Khwarizmi was kind of the starter of really getting some formal, you know, algebraic reasoning skills, algebra was still utilized back in the Babylonian days, even Chinese and other stuff. It's kind of like the whole Pythagorean theorem with Pythagoras. See how Pythagoras was the first one to really formally talk about it? But just because he was the notorious one for the Pythagorean theorem doesn't mean the Egyptians didn't use it before him. So algebra has always been used for as long as we know in the history of math. But where Al-Khwarizmi comes in is he pretty much said, look, this is an algorithm. And he started using that formal language. And you really think about, you know, and it goes back to, I saw the quadratic equation when we solved for roots, and, you know, obviously they didn't call it that back then, but they started realizing with squares, what happens if I get a negative? And it would not be until later that these things would be formally, put and, more sophisticated. But you really think about where algebra came to be and where it started. It really started off with just how do we approach algebraic equations? And how should we think about, where can we apply it to our everyday life, practical situations? That was big in the Islam way of mathematics. So again, to finish up this video here, I really just think if I were to tell my future students about the development of algebra, I would really say it's not about what on paper was formed. It was more about how did they approach figuring out algebra. And they utilize algebra in such a way where, okay, look, let's try to actually think about this and let's figure out how can I create an equation and how should I go about this equation. So a lot of whys and hows and not whats. And it's kind of like going back to the whole Greeks versus Egypt thinking. The Egyptians, they thought about, look, let's get a system out there. Let's just get something out there. We got to trade. We got to figure out a way to tax these people. That's what the Egyptians said. The Greeks, they pretty much said, hey, look, let's think a little bit more formally. And that's how hence the elements, so many things were created. A squared plus B squared plus C squared, Pythagorean theorem. But we think about now, using that thinking process, quantitative versus qualitative. This was a very qualitative way to think about mathematics. And it's not just solving for X. What's the process to solve for X? And that was really highlighted in that first video for Stanford. Bye guys, take care, have a great day.